So this is going to be a little chatty at first. The way we'll run this is we are going to do demos probably for most of the session, probably hopefully the last hour plus change. And feel free to speak up. Everybody can unmute. If you are just hanging out, hacking in the background, go ahead and mute. But feel free to ask questions. I'm going to try to monitor the chat, but not as much as just interrupting. You know, consider this more of a live session discussion. I really do want to take some input and understand, you know, where we need to head with GDAL and kind of into the future for supporting this tool. But I also want to mention the limitations that are currently there. It doesn't do everything. So, but let's go ahead and get started. So there's some front matter I'll do. Let me jump in. Just introductions. If you haven't done anything, if you haven't installed or downloaded the demos, you have time to do that now. Don't worry about this link. It's in the PDF I sent and also the emails I sent. And you could set up your environment in about 10 minutes while we're chatting away. Again, that's optional. And you know, the best thing about GDAL is that it's widely used. And so there's a lot of conflicting information, but there's also a lot of good information out there. So I start off with the top one is just something I've been maintaining mostly for conversion tips, and I'll go over probably about 10% of those examples today. But then there's a lot of good ones. This quick start, this cheat sheet is amazing. The tutorials, there's a really good actual YouTube video that it does a really good background on some USGS topo maps and how things evolve from there. Part 1, 2, and 3 from Rob Simon. There's workshops. Rasterio, which I've been told it's pronounced, is another good GDAL plugin for Python, not our wrapper for a Python wrapper for GDAL, and it is more Pythonic. So I'm not used to that. I know Andrew is a very heavy user for that, and I'd like to hear more stories if there's any good use cases out there. We do have a module. The last module will go over Rasterio. And just in case, a lot of people may think that it's called GDAL. It was originally by Frank Warmerdam, but it's been changed back to GDAL. And that was actually, whether or not that's rumors or not, but Rob Simon talked to that in his YouTube video, that once Frank went to Google for a while, that Google didn't really work, so they went back to GDAL. And I think everybody else called it GDAL too. And there's also there's a lot of good tutorials. You'll notice that there's things talking about GDAL or NASA AIM Stereo Pipeline, how to use some of their tools in concert. And then of course the heart of GDAL, which is spatial data map projections, and there's some information down here. Projection Wizard's a nice little tool to help you define a projection to use for a certain area. It's built on Earth, but it works the same for planets. So, introduction to the workshop. I'm going to run through these quicker than this, most likely. Again, feel free to use the go faster, go slower buttons, or just speak up. And so I do want to get to these tutorials pretty quickly. There's a lot of background in these help pages, but they do need help. I probably will start adding to them. Remember that GDAL is an open source project. They love to have pull requests for spelling errors, for more information, for misinformation. So feel free to do what you can for these drivers. If you think that there's a bad example or maybe a better example, we can actually include that into the help documents. For plans for PROJ 7, PROJ 7 is the map projection library started by the USGS that has been taken over by OSGeo, and I will quickly go over some of the plans for that. This was a project that I'm working on with folks at ESA and folks local, but it is really to understand how to put all the map projection codes into GDAL as a distributed thing, and I'll talk about that more. It's going to be a little confusing, but I only have one slide, so let's jump into it. So I've been at astrogeology for 30 years, started out of high school, and I've been doing mostly support for geologic mapping, some science, and now the PDS. I am an interoperability evangelist, so basically I try to work with groups that do shared data, do shared formats, like the Open Geospatial Consortium, which just wrapped up their meeting yesterday, their technical session, which we talked about GeoTIFF and other projects that they're working on. They are the ones who have kind of made it messy in the web mapping with the EPSG codes, which do not have anything planetary, and so we're trying to work around some of those limitations. It is an Earth-based consortium, so it's a little hard to get them to use. We still bug them every once in a while that planets exist. So I am part of MapSit, which is a group that talks about kind of the NASA planetary data ecosystem. They talk about foundational products, and I'm not going to go into that, but basically it's the products you need and the services you need to make the user community run. And that is, part of that is the PDS, but part of that is beyond what the PDS can do. I'm also part of the Community Sensor Model Working Group, which is a CSM. A lot of people hear me talk about CSM camera models. It is essentially just a standardized API for camera models. It is not what ISIS uses. It is not what JPL uses, but we're trying to head that way. It is a way to share camera models across applications. Applications like Envy and Socket GXP, and we at USGS are trying to support those to make sensor models interoperable. And then there's a little less, a group that's probably moving a little bit to the background because of things like MapSet, but the Mars Cartography Planning Working Group still exists, and they mostly talk about needed updates for defining the planet and stuff like that. Current projects, I am in charge of the Mercator GIS lab, and a lot of things we do, we are funded by an interagency agreement by NASA. We support geospatial formats, web services, tools, and training, and so this is Mercator Lab is sponsoring this, my time to do the materials and host them. I do work for the cartography and imaging PDS node, and that supports archival and the migration from PDS3 to PDS4. Recently, I've been supporting the Mars 2020 landing site selection with topography and orthomosaics to help land. Those mosaics will actually be on the spacecraft when it lands and do some image feature matching, hopefully while it lands. And then behind schedule, but supporting Socket GXP for stereo model or DEM, DTM creation using the CSM camera model. And that's the whole reason why we went to CSM is because it's to extend Socket GXP with your own sensor models, you use CSM, and that kind of shown a big light that says, oh, well, now not only can we share formats, but we can share camera models. And so that's the initial stages. It is again an Earth-based, but we've already modified the standard to support planets. So what does interoperability mean, and why am I an evangelist for it? It does mean sharing data, services, and metadata. It does mean sharing ideas and methods, algorithms. So open source is good across applications, but also domains, which is tricky for Planetary. And I'll talk about that a little more. Examples, text files, ASCII. A lot of people don't think that is a big deal, but that is kind of how we transmit and share files a lot. Websites, of course, is a prime example, and then graphical images, JPEG, PNG, and GIFs, and those all work pretty much in any application. But when you start getting into different topics like software code, now there's different languages, C++, Python, there's raster data, there's formats, PDS, GeoTIFF, VICAR, FITS, and 150 plus image formats. And why the hell do we need that many formats? Who knows? But they exist and they will continue to grow. So we are trying not to, I think that the goal is to try to use what exists and not create those. But I'm very, every time I see another format or a change format, I cringe a little bit. And the same with vector, there's CSV tables, shapefiles, GML, well-known text, JSON, and GML again for some reason. But it also means interoperability of map projections, and that includes the size of the body and the actual equations used in the map projection. And that is not simple, as we found out in the high-rise label. There is a problem that has existed for about a decade, and we're still living with it because of a map projection confusion. It's not really a bug; it's more of a different use case. And so I actually did have some high-rise data to show how we fix that, but I've taken it out because it was too big for the package. Metadata interoperability, again, PDS, FGDC, NASA diff, ISO, there's all sorts of different styles of metadata. Symbologies is big for my community as far as mapping goes. So in a geologic map needs to have consistency. It needs to say that a black line means something, a dashed line means something else, and that it is consistently used across maps. That is so that it is readable, so that someone can jump from a map to a different map and understand the context of the symbol. And so that's a huge issue for us. And for geologic mapping, one of the reasons we've always kind of stuck around with ArcMap is because of its capability to do FGDC, which is a federal group, FGDC-based symbologies for geologic maps. We have worked with others in the community, Alessandro Frigeri and Andrea Nass and others, to support these standard symbologies in QGIS. And then, of course, methods and algorithms, slope, horn. We have for rover landings, we have slopes at a 1, 2, 5 meter baselines, which allow you to say, is it safe for the wheel? Is it safe for the whole base, the whole rover? And then applications, can we have applications be interoperable? So how does GDAL fit into all this? Well, the goal is to share, and GDAL facilitates essentially the raster data component, a little bit of the map projection, well, a lot of the map projection component, and a little bit of the metadata component. It doesn't do a lot of these other things, although GDAL is used in a lot of applications, so that if you support a format or an idea in GDAL, then it actually might get used in several applications. So why did we start supporting GDAL? It's kind of a fun story. Back, I'm going to reset my timer. Back when we had ArcView3, really old school desktop GIS, right after ArcInfo, that someone wrote a plugin for GDAL, and you could distribute it as an extension to ArcView3, and it simply allowed you to write out a new file as a GeoTIFF, and not even a GeoTIFF, just a TIFF with a world file, which is a minimal style georeferencing image. And that kind of flicked on the light to say, okay, GDAL is this nice tool that allows me to do raster things with my GIS. And so in 2005, 2006, we started to write a driver for it. And probably the smartest thing I've ever done was to take the code that I wrote, and then I paid the GDAL maintainer, Frank Warmerdam, to actually update it, fix it, and incorporate it. So money well spent. Number one, the only reason I could do it back then was because of the NAFTA, North America Trade Agreement, because Frank is a Canadian. I believe he's in the US now, but Frank is the one who started GDAL. And because of the exchange rate, the little bit of money I was able to give him was very well received in Canada. And so, again, money well spent for an open source project. You know, it's okay to write your own, but to actually fit it into something that exists can be a little tricky. And so, you know, I do recommend supporting open source projects if you can, even if you do write the code. In 2007, because of the success of the original readers, we decided to add ISIS3. It was not ISIS4 back then. ISIS3 read support was added. And again, the focus here was read. Being able to read images. We weren't talking about writing yet. We just wanted to be able to read our formats into different, for conversion and for application use. Sebastian Walter in Berlin added, based on these other drivers, added a VICAR read support. And then in 2017, GeoFITS was added. It was under a Vespa project from ESA, and that was to add GeoHeader, a GeoComponents, a geo extension to the FITS file. And that's still fairly new. We're still kind of testing the waters for that. But it allows you to properly define map projections within a FITS file. In 2017, we also added the ISIS3. I'm calling it 3.4 because ISIS now is at version 4. ISIS 3.4 writer. And that was a big change for me to support writing, to want to support writing. That was always, I tried to stay away from writing any formats out besides GeoTIFF. But I think it's an interesting use case, and we'll see if it's successful or not. 2017 and 2019, we've had 2 contracts to support PDS4 reader and writer. And it's not only for images, but it's also for table, tabular, or vector data. And I'll talk about that more. In 2019, the VICAR driver, with approval from Sebastian and folks at JPL, you know, 90% support. It's not the perfect driver yet. Was completely kind of rewritten from the ground. We actually looked at using VICAR IO code, but it was deemed to be too hard to fold in its style of writing into GDAL. So it was basically rewritten from the ground up, and testing was done by Sebastian and others. And it's still in beta, it'll be interesting to see how far that goes. And then in 2020, we're hoping to release this PROJ 7 update. So let's go. So the main goal for GDAL, what are we trying to do here? We really are, the original use case was to convert to GIS formats, convert from our PDS, ISIS, VICAR things to GIS formats like GeoTIFF, ENVI, even ASCII rasters, GeoJPEG 2000, even though that's a naughty word for everybody nowadays. And also support derived map projected data. There was no attempt, even though it will work in some cases, there was not really any attempt to focus on supporting raw EDRs. And a lot of people might not like that decision, but I wanted to make the case that GDAL is for derived science-ready data. EDRs, or engineering data records, that are stored from the mission should be calibrated, map projected, orthorectified before they go into a GIS. And so I think there's a very high bar to go from an EDR to a science-ready product, and that GDAL is not suited to do that. You need to use programs like ISIS or VICAR or you know, any of the mission processing pipelines. You know, even CRISM uses ENVI. So you don't have to use ISIS or VICAR, but you do need to do some pre-processing, and GDAL was never really meant for that. Now again, it can support some of those, but it's not its primary use case. And then map projections. Again, most derived products means it's in a map projection, which has gotten tricky with the use case of true 3D asteroids, comets, and bodies. So that's been a challenge. And then the last goal was the ability to use for processing and scripting. And now that's basically turned into Python tools. When I first was writing against GDAL, it was using Avenue, which was the language used in ArcView 3. And then Perl, and the good thing about GDAL is it's wrapped for almost all languages, Java, JavaScript, even, and of course it's written in C++ or C, so it's pretty easy to wrap. But as one things I didn't understand when we first started to support GDAL was that it would actually propagate, those drivers would propagate throughout applications. And so suddenly we noticed that we started to get support for PDS and ISIS in programs like QGIS and Saga GIS, Marone, Esri's ArcMap and ArcPro, and even things like Map Server. And because Ross, you have to correct me if I'm wrong, but NASA AIM Stereo Pipeline uses GDAL as its main I/O, or one of its I/O. And then most recently, and this has been a couple years, but you'll start, even tools that were built pre-GDAL have sort of transitioned to GDAL, like generic mapping tools, and those are popular tools used by the LOLA and MOLA teams for surface interpolation. GrassGIS has been around for decades, and it transitioned to use GDAL. And then one of the things I actually switched, I stated I was going to use QGIS. I'm actually going to use TUIView, which is a real simple raster viewer that supports large files, and it's a nice little quick viewer for Linux and all platforms. So installing GIS, I'm not going to do this. I did notice that in my email had a bug. So one of the things I'll show is how to quickly install Rasterio into your environment if you've already done the instructions from the email. The actual instructions from the PowerPoint are correct, or the PDF. So installing, okay, I'm gonna zoom ahead. GDAL. This was an interesting article from a guy from AWS, Amazon, that just came out a couple weeks ago. But this is kind of the reality. GDAL may not be a household name, but it is everywhere, and it helps us to map everything. And so this is a cute little article that talks about how GDAL kind of sits in the background and does its thing, and it's nice that it's getting some recognition. And actually, the main person who's taking care of GDAL right now, Evan Ronald, is actually mentioned and quoted in this article. So it's a good little read. And a lot of people think that GDAL is going to do everything for them. It's not. It is a library. It is for scripting. It is for writing programs against. It happens to have a bunch of nice utilities, but those utilities can be a little bit hard to get used to. There's weird options, but it is something to write against. And so that's the key. That's why it's used in so many applications. It is completely open source and community driven, to the point where when folks try to add proprietary drivers, they get jumped on, which happened last month. And it's just interesting to see how protective folks get for making sure that everything used in GDAL. And it doesn't necessarily mean that proprietary formats or proprietary drivers can't live in GDAL, but at a minimum, they should be supporting GDAL, financially, or as an open source project, even if they can't make their code public. And how does that work? GDAL actually allows you to plug in existing binary formats or existing builds into itself as during runtime. So it's very modular that way. If it's not built with it, you can simply drop it into a library location and it'll work. So, excuse me, handles many formats, over 150. Again, kind of crazy that we have this many image formats. The best thing it does, or the most widely used format, I would say, is GeoTIFF, for GIS anyways. Started in 1989. It's been around for a while. It has been a project of OSGeo since 2006, and that was GDAL version 1.3. It is a MIT X open source license. and there's lots of code and lots of Python code. And there's a presentation from Yvonne down there. So what domain, and I mentioned this briefly before, GDAL is geospatial. It's tied to a planetary surface. This makes it very hard for GDAL to support all the dozens of planetary domains we have, atmospheres, interiors, and it's actually hard for it to even to support comets and asteroids now because of their 3D nature. And so trying to get GDAL used across the planetary science is near impossible and probably shouldn't be done. So just understand its limitations. It is geospatial. So I'm going to jump straight ahead into installing GIS. There's a lot of ways, installing GDAL. There is a download page. It can get really confusing, and I think the thing that changed for me was Anaconda. Anaconda made everything kind of happy. It can be a pain, but it is available on all OSs. It's not just for Python, as a lot of people think. It's just a simple environment manager that allows you to quickly install GDAL on any OS, and pretty amazing. ISIS has switched over to using Anaconda environments. Again, ISIS is not Pythonic, or is not built in Python, so it's just simply an environment library manager, and allows you to keep separation of different packages in their own environment, which is really where it shines. There are OS specifics, and this is kind of how I grew up with GDAL. There's for my Mac, there's a package. Sounds like a Pokemon person, but King Chaos has been supporting a GDAL build for Mac forever. We'll see if he ports over to the new Mac chips when they get it. I guess the end of this year or next year. Windows has this thing called OSGeo for Win. If you're familiar with, there's a Linux installer, Sigwind, I guess, has a kind of an installer that is similar to OSGeo for Win, where you pick the different libraries you want and you hit play and it installs for Windows. Linux, there is a Debian unstable build. That just means more recent. But on Linux, it's kind of expected that you build it yourself. And so there are pretty good instructions. I will admit that it's gotten harder with the new version of PROJ and the database requirements. It does require SQLite to be built alongside. So it used to be pretty easy to build. It's gotten a little more complicated. So I do recommend the Anaconda route. So for this workshop, this is basically it. This is how you get it. And you'll notice that I've added 2 new requirements, Rasterio, and then kind of an optional QGIS. Rasterio, again, is that Python wrapper. That's kind of a better version of the GDAL's Python API, the current API that comes delivered with it. But Rasterio is gaining quickly, and I admit it is nice once you start using it. You'll notice that for this workshop, I use GDAL equals 3, and that allows me to tie to almost probably 90% of what's new in GDAL. If you really want to get the latest versions, you're going to need to install 3.1, which will probably break compatibility with a couple of these tools. I'd be surprised if Rasterio supports GDAL 3.1. It's been out for a couple months, but this is where you'd find the latest PDS4 updates and the latest VICAR, the real big VICAR update. And again, because it's an environment, when you fire off your Anaconda terminal, you always have to activate GDAL 3. And the reason why I specified an environment name is that it keeps it, again, siloed in its own little area instead of doing it in kind of the base area of Anaconda. So highly recommended. Always create an area for this to be installed. So if you haven't done it yet, feel free to conda install this, and I'm going to bring up my window real quick. I still have it open. And in case that you follow the email, I'm actually going to do this again. Hopefully you can see this. So this is basically all you'd have to do if you followed the instructions on the email in your current environment. Notice that GDAL3 has been activated. So I've done my Conda activation. And for anything Conda, Mike is actually doing a demo later. So hopefully we'll record that and we can watch that later if you haven't signed up for it. Fire off Conda install Rasterio, and magically it goes to Conda Forge, which is a kind of a quick release area, and you'll notice that it says, hey, oh, that's already, it states all the packages have already been installed. I've already done it. If you haven't, you hit yes, and you're good to go. So, yeah, and as Sebastian said, Conda is a really great option to support different versions of GDAL for testing. So if you need to go all the way back to 2.1, you can install your own little environment and hopefully get that from Conda Forge. GDAL is under a quick release cadence, probably every 6 months or potentially even faster. They do a release candidate and a final release. So it's hard for all the tools that use it to keep up with it. So while I said we've added PDS4 read a couple years ago, it probably still doesn't exist in tools like Arc Pro. It does exist in the more rapid release cycle for QGIS, but the latest version that just came out in 3.1 will probably take about 6 months to get into Q, maybe another year to get into ArcMap. Who knows? I don't know the cadence of the other packages like Saga GIS. So that's basically it. But those instructions, and to test is simply just run your GDAL info, which if you start using GDAL, you'll get very comfortable with. And we can check the version. When you build it yourself, the version will be released 2999 or something like that. But I do, to be able to test GitHub, quick GitHub releases or daily GitHub releases, I actually do build it myself, and this is a good way to test to see if you're running on the version you built. One thing I actually skipped over was there's a new feature that GDAL has been doing for about a year. They actually release a Docker version of the nightly build on Ubuntu and Alpine Linux versions, which under Docker, you can run it under any OS, Windows, Mac. And that's a really great way to get nightly builds to test if you're actually writing, or if you actually do a pull request and you need to test your code. Hopefully you're not doing it in the Docker, but it's been pulled and you need to test it or have others test it. Docker is a really good way. And I think I have an example. Some tips, I'm not going to go over this. There's a little, the hardest thing to wrap my head around when I first started this was, since I'm not used to Docker, was defining where am I working and where does that map to in this Docker machine. And that's the trick here. So parent working directory maps to this fake area called data. And so now and that just means where I'm sitting. I've made this path data. I guess I didn't have to, but so a Docker run without installing anything but Docker, and then downloading this Docker image of GDAL, I can run GDAL translate using the latest and greatest nightly build from VICAR to PDS4 is the example I'm showing. So a really good way to think about not impacting any. You have to have Docker, which does probably require admin installs, but once you have a Docker running, really easy to test things. And that, I don't know if they support different versions. So just a kind of a nice quick tip for learning GDAL. QGIS has GDAL built in. It uses GDAL as its raster engine, but it also has a bunch of the command line options as GUI. So underneath this GUI called GDAL translate or convert format, it allows you to pick the input layer, and you can pick what type of compression and the output data type, and it will build the command line for you. A lot of applications are starting to do this. But essentially, this helps me understand that, oh, okay, I understand that -OT, whatever that means, is set to uint. And by the way, that means output type. -OF means output format, and it's defaulting to GeoTIFF. And then the type of compression. This -CO means compression options. So as I mentioned before, GDAL is a library, but it does come with these helper utilities. But I'm not going to tell you that they're easy. They can get confusing fast, as you'll see with some of the command lines we run today. So quickly to run into what's new, there's a large section for PDS4 that we'll skip over, but you can look at it in the notes. So what's new? ISIS3, we've added write capabilities. Before GDAL, we specifically supported kind of a minimal set of metadata within the ISIS label to understand the node data and the map projection and not much else. We can now, GDAL has been updated to support or try to read in the full ISIS label. That doesn't include everything that ISIS has. ISIS has a ton of different areas, and including binary sections of SPICE and all sorts of fun stuff. So GDAL does not support that. But it does try to support the main block of metadata and can fold it straight into a JSON blob for Python. So I've always kind of used within Python, I use the PVL, which is under Planetary Pi now. PVL is parameter value line library that allows you to read in things like ISIS and PDS3 labels. That is probably mitigated somewhat because GDAL now has support for most of the metadata, but it's still, PVL is still a good resource to use if you just need the label. Under the contract, the code delivery was not only the code, the reader and the writer, but also unit tests. And those are a really good way to understand how to write against the ISIS driver. So underneath the unit tests, you'll find a bunch of useful code. So one weird thing I added to the ISIS writer was something that ISIS doesn't support, which is the ability for GDAL to create an ISIS label pointing into a raw GeoTIFF. And what do I mean by that? That means that there's a detached ISIS label pointing into a GeoTIFF. And ISIS will understand that label, but it doesn't understand the GeoTIFF. So I guess it does support it, but it's not fully support because ISIS does not understand, it does not how to read or write GeoTIFF. So this is one way that you could distribute a file in GeoTIFF with an ISIS header pointing into it. Now, I also allowed the flag for TIFF compression, which absolutely is not supported in ISIS, but I'm hopeful that someday ISIS will support some type of compression. And the largest, one of the biggest changes that we have yet to kind of understand is the addition of virtual file systems into the ISIS driver, which means that an ISIS file or an ISIS formatted file that's hosted in Amazon or Google or compressed in a tar or zip file can actually have direct read in GDAL. And if you look down here, that is AWS and Microsoft Azure and Alibaba Hadoop, OpenStack Swift. So any of the files, any of the ISIS files that are stashed in these type of network or virtual file systems are now supported in the driver. And we just don't know how that will be impacted yet. VICAR, a huge, large refactor of the existing version by Sebastian. It we kind of had to go down this road, but now it does allow write capabilities. It was based on what we did with ISIS, so I think most all of the VICAR keywords are can be accessed programmatically in C++ or Python, most likely in a JSON object. But and that has yet to be very well tested. It also has 17 unit tests were delivered as part of the contract. One of the goals was to support all the VICAR bit types back to VAX, funky style, and it actually supports, VICAR does support compression called basic and basic 2. I have no idea what they are. I assume they're a run length encoded or some type of gzip. But it does support compressing into those or uncompressing out of those, and it also added the virtual file system to VICAR. So, I'm making the case that currently JPL, the folks who use VICAR probably can't use this driver yet because it doesn't do everything they need. Number one, GDAL does not have support for rover map projections, ground-based map projections. GDAL also doesn't have one of the VICAR use cases, which is being able to put in RPCs or codes for emulating camera models into labels. It was outside of the current contract, and so. But again, we have control over this format, so hopefully either we can continue to upgrade that for their needs. PDS4, it was added in 2017, and we've as PDS4 changes, we've updated it with a couple other things, GIS and raster format. I'm sorry, raster and vector. So the PDS4 driver is unique in that it supports vector tables within the same driver. That is a little bit odd. It uses the other sister library to GDAL called OGR, but it is within the same driver. All the PDS4 keywords that are XML are accessed programmatically. You can load it into a JSON object straight from XML or back and forth. One of the things that we've added based on the ISIS driver was the idea that we can have a PDS4 label pointing into a GeoTIFF, and that requires it to be a raw bit stream. And something that just happened in 3.1 was we can actually create a PDS4 label pointing into an existing GeoTIFF, and that will actually test if the GeoTIFF is tiled or raw or compressed, which is not allowed in PDS4. Not only did that work for PDS4 into GeoTIFF, but actually this little flag allows you to do, I think you can set a PDS4 label next to an existing FITS image, next to an existing INVI, I believe, and ISIS file. It doesn't do everything. And it's not just a blanket statement. You actually, to be able to support writing to an existing file, there had to be a little function added to each separate driver. So a new little driver, a new little section for FITS, a new little section for ISIS that actually allows it to check whether it's compliant. So it just doesn't open it up for every image format. Just in, GeoTIFF was initially approved by the PDS data working group last week, which means that hopefully if it passes through full approval, we will be able to support GeoTIFF raw as an PDS archive with a PDS4 label that's fully descriptive of that GeoTIFF. So interesting change, something that I hope changes how geologic mapping and how archives are built from missions, so that we can actually support an immediately usable format, GeoTIFF, and the PDS4 archival requirements. Code is all under open GDAL release, and PDS4 also supports this virtual file systems. So this is from a different one, but it's good for context. The original version was available in 2.3. It had 18 unit tests. It's probably been upped And this is a weird one. It does have vector and tabular support for PDS4. So it understands how to go from any number of databases straight to a PDS4 compliant table, or any number of GIS formats to a compliant PDS4 GIS format. And I'll talk to that in a second. But I do want to rein in expectations for the PDS4 driver. GDAL, again, is very limited in what it understands in the metadata world from a PDS or from a mission label. So it does require that there's some upfront work or some back-end work once you use GDAL on a PDS4 label. It doesn't know what the author was. GDAL doesn't know what the mission was unless you tell it. So basically, if you feed in GDAL a good PDS4 template that has most of that information that GDAL doesn't know about, like author and references and things like that, and the lid vid or the planet it was even on. I guess GDAL does know the planet, but how it doesn't know how the style doesn't have all the mappings of how to get to that planet in PDS4. So that is something that the user still needs to do. And there's a lot of tools out there to help generate those PDS4 templates. So what is GDAL useful for? Well, again, GDAL is for PDS4. Its main goal is to be a reader, not a writer. So once PDS4 starts getting populated out in the wild as derived data products, we should have support, direct read support in QGIS and for conversion and in ArcMap and hopefully other applications. AIM Stereo Pipeline should have direct support from GDAL for PDS4. And that's full stop, read, but it does allow write and with help. And so there's different ways to help GDAL along. You can use tools like PVL to gather the metadata and then pipe it into GDAL, or pipe it into a PDS4 template and then run it through GDAL. And so there's some examples here at this GitHub site talking about how do we archive ISIS files. PDS4 vector is what we call a GeoCSV. It's a kind of a weird format that's existed for several years. Essentially, it's a CSV table with a well-known text geometry string tagged onto the end. There's a lot of information about that, but basically, this allows us to archive GIS style files in PDS4 without the need for shapefiles, GML, or geo packages. Essentially, it will make your shapefile even more ginormous, but it is a way to make it archive ready. So essentially, you have a CSV table, and then you have this giant well-known text geometry line string, which is a single field. GDAL supports the creation of that, although it's pretty easy to script yourself. There's minimal templates to show you examples, and then there's some introductions. So I won't go over this, but PDS4 does support well-known text geometries because it is a well-known standard. It's just an encoding. Because it's ASCII, it made it easy. The biggest thing that I'm really had trouble with this year was part of the original contract was updates to PROJ 7, and again, that's the projection engine behind GDAL. We actually had to add, I've been wanting to do this for a while, 2 new projections to support Planetary. One was actually in PROJ but not exposed to GDAL, called point perspective, and that's also known as near side perspective. Another one that is somewhat unique to ISIS and PDS is oblique cylindrical. It's a twist on the one found out in the wild. It's used in Cassini archives, and it is somewhat of a unique version. There's a slight tweaks that had to be made, and so there's a special version of oblique cylindrical in PROJ that GDAL supports for ISIS, and if not PDS4, it'll be turned on for PDS4, and I think it was turned on for PDS3. It's still, that is very beta, and we still need to work on testing that for all cases. Oblique cylindrical is nice for really long noodles that go from North Pole all the way down to South Pole, and it allows kind of a rotation during that. And that's not the unique part, but the way that it was implemented in ISIS was unique. So to be able to undo that was kind of tricky. And it's not, ISIS didn't do it wrong. It's just one of these things where different people did the map projection slightly differently. So unfortunate. As of, so we have this thing out in the wild that some might be familiar with called IU 2000 codes, which has never been admittedly, well used, well understood, perfect by any means, and we're trying to get it better. And the only way that we could get it better was to lean on the fact that a new standard came out for projections called Well-Known Text version 2 projection API. It is an OGC ISO standard. And as of IU 2015, once this is pushed, all the definitions will be in this new projection string. They'll be released in GDAL. Hopefully they'll be useful for web services. It allows for east-west longitudes. It allows for ocentric-ographic, kind of. That's where we're stuck. The ocentric keeps on biting us. And so we're going to either have to change the standard or just live with the limitations. And that's part of the issue with the last IU 2000 style. It nicely defines the W0 locations. It doesn't set that to 0. It just says that, hey, I am 20 kilometers from Hunkau on Mercury. So it actually specifies in the well-known text string where the center reference is, which is nice. It doesn't really do anything. It's just a nice feature. And while we will support the IU codes on triaxial bodies, GDAL doesn't do triaxial. So big limitation, but these codes will have a triaxial version. It just won't be distributed with GDAL. And this is one of the use cases for point perspective. This is a telescope outside of USGS and Flagstaff that takes, I don't think it's nightly, but takes a lot of images of the moon and actually helps calibrate a lot of satellites in orbit. Project called Rollo under Tom Stone, originally by Hugh Kiefer. But basically, point perspective emulates what you see from a ground or far away on a spacecraft. Okay, let's jump into it. Format conversions. So hopefully you've installed your environment. If you have and you've unzipped it or untarred it, you'll find a directory that looks like this. There's CTX Horizon Test. Sorry, I tried to go for a different planet, but I couldn't get away from Mars. And there's only 4 notebooks that we're gonna pounce through. Before I start this, I think chat's been cruising by, but let's feel free to have any questions. I see some about GeoCSV. Is there any questions that you guys want to ask before we get started? Go ahead and unmute yourself. If you're too shy, that's okay.
Trent, this is Michael.
Yes.
So I was wondering, you mentioned QGIS often as well, and there are some heavy QGIS users here. So you said that or nobody can automate metadata, right? But maybe if QGIS would make really good productive use out of something that every mission uses, would that be a good argument to then argue for it that it's being entered as a handleable parameter in the GDAL format in general?
Yeah, so you mean having QGIS have the ability to look at the full label? Is that what you kind of mean?
Or I mean, and that could start slow, but I could imagine that QGIS could make really good use out of things that are written in the GDAL. And I guess currently one has to manually tell QGIS about the label data, but if that label data could be just taken from the format, and QGIS would be working better because of it. Maybe that's an argument to add it to GDAL, at least partially.
Yeah, so I mean, obviously it does understand a lot of the information in the label, but it's mostly the geospatial components. I know this is a tiny window. One reason why I decided not to use QGIS for demos, but and I know you can't see this, but essentially, you know, a minimum set that QGIS needs to know is obviously the image bit type, the width and height, and all that good stuff that images have. But it also knows the CRS, and it knows how to interpret. It knows how to make sure the projection. It knows the georeferencing. It knows no data for the most part. Although we just had a discussion in ISIS about the support of multiple no datas, which has always been tricky in GDAL. And there's a little quirk in ISIS now that when you export an ISIS file using GDAL, it writes out a mask, which I probably need to have that as an only optional thing. And the masks are generally used to support multiple no datas or transparency levels. So it's a weird thing. GDAL on itself only supports a single no data value. But for the most part, what we're missing is, wouldn't it be great if QGIS through GDAL also was able to fill out all this other stuff? But you know, in the PDS4 there is no fee section. I don't know if there's a license section. This is kind of based on FGDC metadata. So if there is FGDC metadata next to the image, it would propagate into here. So yeah, it's hard for me to understand. It's hard. Well, QGIS understands what it needs for the image for the most part. It doesn't have the full label. But I think programmatically we can get at it, and let's talk about that. Because as QGIS gets heavier Python support and Jupyter Notebook support, then it might be really easy to do plugins and other things to actually use the newer capabilities in GDAL that understands how to parse the whole label. Doesn't know what to do with it, but it knows how to load it into memory for you. We might be able to actually propagate this into a QGIS plugin. And I will say
why would you do that when you could just use the PVL library to do that exact thing, right? Like, why bend over backwards to make it run through the GDAL driver?
Because then you wouldn't have to. You're right. You could do PVL straight into QGIS, but it would already have GDAL already has native support for the full label now. I think that's yet to be tested. And again, it's only for ISIS, PDS4, and VICAR. It doesn't support all the other ones. So yeah, I mean, PVL is the right way to do label parsing. And if we can integrate PVL into QGIS, that would be amazing. That's another way around it too. But I think there's capabilities in GDAL drivers now where we could load the full label into memory in Q, and then we have to tell it what to do with it. So that would be the trick, I think.
And then we need to get back to the old idea of attaching labels, because managing two files, I think, is just stupid.
Yeah, you know, I waffle on that, and the reason why I do is that there's a lot of things that are useful in some of these labels, some of these detached labels. For example, one of the things that GDAL does is called this auxiliary thing, and it stashes a bunch of information that a lot of drivers or a lot of formats don't support, like stats. Like you can't throw this block of text into a JPEG or a PNG or a GIF. So having these other labels are important, or these
I don't understand that technically. If you have everybody follows a standard of a separation of where a label ends and where the data starts, why is it not possible to have anything you want in the label and in an attached label?
Well, because not all formats do that, Michael.
Exactly.
GeoTIFF, yeah, sure, you could do that. But like if you wanted to do other things, yeah.
Yeah. So
And you would say, well, you shouldn't do other things. You should just use the one format, right? I get that. But people, as Trent well knows, people want to do all kinds of crazy stuff, and you need to either enable them. You basically need to enable them because they're going to do crazy stuff anyway.
yeah, I mean, just think about one of the things that we talked about. So you can extend GeoTIFF to whatever the hell you want, but they're weird. I mean, they're weird little binary things inside the label, and it's awkward. And you know, most people, you just want a simple. You don't want to throw everything that you could in a GeoTIFF that you could, right? And again, GeoTIFF is not necessarily the right solution for everything. There's a lot better formats for web streaming out there, even though GeoTIFF is breaking ground in that field for web streamability. But yeah, and that's the problem. That's why there's this furious influx of new formats because of technologies like net and cloud. People need new formats to support those better, and that's just the reality of it. Also, you know, as much as you want to hound on people to use structures like HDF for their formats or XML, people just don't. So yeah, it's a hard battle to do when there's 150 formats out there. Sidecars also enable things like pyramids across formats. So ISIS doesn't support pyramids, which is multi-versions of itself, different versions of itself at different resolutions. But because I can add a sidecar next to an ISIS file, all of a sudden the ISIS format supports pyramids. So sidecars, I know they're a pain, and it's getting worse, but it's just, I think it's going to be a matter of fact, unfortunately.
Is sidecar a term for anything that comes with the data, like a label or anything else?
Yeah, it's okay. Something that sits next to the main data file.
It's another term for a detached label. Yeah.
Detached label. Yeah. So you have the main product, and then you could have multiple sidecars. Hopefully they're the same. Hopefully they're the same, you know, name, but they don't necessarily have to be. Yeah, and especially, you know, as you get into the cloud, you don't want to have to deal with 5 files. Either does the application. So yeah, I understand that.
Well, so if you want to always a use case for my data manager then.
Yes, exactly. Well, and think about the everybody's starting to use databases to hold rasters now. Postgres has a raster version, and so now you're getting into, you know, things you don't even have files really. You know, they're hidden away in some database. If you want to follow along, go ahead and fire off. If you'll notice, all I did was from my Ubuntu window, but it could be Windows, could be Mac. I fired off Jupyter Notebook, and I named the first file conversion. And I imagine most people are just going to follow along. I did this in a kind of a weird way because I wanted to be sort of self-consistent as I update these and fix them after this workshop and post them. But I wanted to make sure that the requirements are different per. Although I believe this one I cheated, and I think I use Rasterio at the bottom. But I wanted the data for the lessons, and you can see here. Here's an example of sidecars. This is a GeoTIFF, and it has a sidecar PDS3 label. Sorry, PDS3 label, and a sidecar ISIS label, and I could have a PDS4 sidecar. So I could have 3 detached labels pointing into a single pixel, just in case somebody, and I could have a VRT pointing there too, just in case someone comes along and goes, I don't know what PDS4 is, I want to use PDS3. So, you know, hopefully we don't get into that, but PDS4 is a sidecar label to the actual image data. So you'll have to get used to it in PDS4 at least. So running through a Jupyter Notebook, if you've never done that, once you go into the cell, you can hit Shift Enter. If you ever break, you can interrupt, you can restart and clear, and you can shut down. But essentially, Shift Enter is how you move forward, and you can edit those cells as you go along. I wanted to do it because this allows me to print out the information just in a nice environment instead of a giant terminal screen. And I can keep my notes on the screen. But essentially, I've done these variables. So this is Python Python comments. The command line, you would simply type GDAL info. And notice, just for giggles, if you want to be friendly with Windows, if you use a forward double slash, it makes it compatible with Linux and Windows at the same time. It's a nice little Python trick. I don't know if it's just Python. But anyway, so here's my variables with the images in my CTX//TIFF and ISIS3, and I just want to run through within a Jupyter notebook, and then don't give me grief for doing it this way. If you do a bang in front of the command, it actually runs it in the terminal. So this basically just ran that in my Ubuntu Bash terminal, and this is the minimal thing that you want to do before you try to do anything with GDAL on any image, is you do a GDAL info on it to see if it's supported. And if it comes back with some single line error that says, I have no idea what this is, you're basically hosed. And there's either a problem in the label or there's a problem with the file, but most likely it will not be supported in GDAL without updating it or finding the problem. And I say that because there are a lot of archived files out there in PDS3 that just are not standard, or they might not have the exact tweak we need in GDAL to support it. I think Chase and Ross and Mike, you all know how hard it is to support the various PDS3 labels, and GDAL has the same issues. So at any time you want GDAL to do something, first run GDAL info. And this gives a bunch of useful information like the map projection. If there is no map projection, say it's an EDR, it'll just be an empty string. But it also gives information like, I've already built stats on this, but in general, it'll give you the stats in the upper left corners. And what is this? This is the pixel coordinates, the image coordinates in meters in that map projection. And it does give you the lat lons, although I'd call that an approximation for the bounds. I mean, it is precise based on the map projection, but does the data really extend to those pixels? A lot of times it's confusing that ISIS pads past the map projection boundary by a half pixel or a pixel. And so you'll actually get boundaries that extend beyond 90 in latitude or minus 90 south latitude. And you're like, how the hell does that happen? And it's because of the padding that ISIS does. Hopefully before that gets archived, that's cleaned out, but a lot of times it's not. And so I wanted just to show you that it's really important to understand that the first thing you want to look for is the driver too. Even if this is named .jpeg, it will understand. It will look at the header and understand that it's a GeoTIFF, even if it has the wrong name. And why am I saying that? Because I'm going to actually try all three of these files. I'm going to run the ISIS version, and you'll notice that, oh, hey, it says I'm using an ISIS label pointing into a TIFF. And you can see that the metadata is different. Every single parser is slightly different. Every single map projection parser is slightly different, although it's trying to get it into the same final internal map projection need that GDAL wants. And you'll see that there's no stats. I haven't built stats on this label. There's no sidecar next to the ISIS label. So it doesn't know how to peer into the GeoTIFF because I told it not to use the GeoTIFF. I told it to use the label pointing into the GeoTIFF. And this is exactly how the PDS4 driver will work. It will be a detached label pointing into the GeoTIFF, and programs like GDAL or PDS Viewer or other PDS4 viewers will not even know that it's a GeoTIFF. The only reason why it points to this is because it's telling me that it's using this for the pixels. Although it doesn't even have to understand that it's a TIFF because it knows how to skip over the TIFF header. And then here's the PDS3, slightly different, kind of similar. There's some old code in here that we probably need to remove, talking about local radiuses. That was a tweak for ocentric issues. And one of the things that we started to do with the ISIS, the PDS3 driver was, I actually didn't initiate this, someone else in the community did, was, hey, let's at least give it some metadata. And so if the PDS3 label has this information filled out, it will report it. PDS3 is the original, actually as the ISIS2 was the original driver. PDS3 was, I can't remember which one was first, but so it's probably the most basic driver out there, and it hasn't really been updated besides folks from the community updating it. You'll notice the pixel size and meters, always in meters unless you're in decimal degrees. Origin, so all good stuff. But I just wanted to point out that just because that it accepts all, it understands all these three, and each one of those are different drivers, even though it's pointing at the same pixel file. Just as a tip, it's not a great tip, but if you have an issue with a file, you can turn debug mode on. And all that does is it talks about, it kind of walks you through the code and says, okay, this is at this address, it succeeded as GeoTIFF. And it actually goes, hey, I am a GeoTIFF, I can open you. But then it jumps down and says, nope, I'm going to succeed as ISIS3, and I'm going to open you as ISIS3. So it allows you to kind of look at what the code's doing. And it'll tell you how it closed. But, so if you're starting to get errors, this might help. Probably not, but debug mode is a nice feature. And then immediately, we go into, well, what do we want to find out about the image? We want to find out the min-max. Okay, so it lists the min-max. I can turn that off and I can calculate stats. I got somebody making noises.
Oh.
Thank you.
Sorry.
I've got stats. And again, it just does a very, this can take a while. If it's a terabyte file, it can take a long time to gather these stats, but once it's done, it usually stashes it into the GeoTIFF or into a sidecar. And that can be confusing if you actually change the image outside of the stats. So sometimes if you need to force recalculation of the stats, just run it again. And actually one of the nice features that I actually don't use very often is just a real simple histogram. And it's not going to plot anything. It's just going to give you these values. But you can copy and paste these straight into LibreOffice and just plot it. Just copy that string. You have to fight with it a little bit to get it in. Let me see. Excel was actually a little easier. I just copied and pasted using a special, there's a paste, import text paste and you can just paste these into columns and then plot it. And it doesn't do anything for you because it's listed as 255 bins, but at least it gives you a look of it. So, within a minute, you can have a little, if you don't have QGIS open or you don't have a program open that knows how to do histograms, you can quickly get that from the command line and another program. And then the meat of this lesson is GDAL Translate. GDAL Translate, this is kind of the craziness of GDAL. These are and if you didn't know, tip, if you click these the right way, you'll get them to collapse or unfold. This is what is currently built as standard in GDAL. And these are all the stinking formats that we support in our community. And this is just geospatial, UG. And there's additional ones on top of this that you can build outside of here, like Kakadu, which the high-rise team uses and ISIS uses, is a JPEG 2000 reader writer that doesn't exist in here because it's proprietary. But yeah, I mean, the fact that we have this many image formats is why GDAL is important. It's just kind of crazy. And we haven't helped the fact by making our own in ISIS. And you could even say that in PDS too. But you'll also notice it does use CFITS.io for FITS. It does have a JPEG open driver, which is not as good as Kakadu by any means, but it's actually been funded last year to become pretty darn good. So this driver does a decent job with high-rise now, and it's built part of GDAL in the latest versions. And the other thing you'll notice is that GDAL does have support for web services, and that's kind of weird, but you can actually request conversion from a WMS, from some funky web server, into a file on your local disk. Without doing, within 10 minutes, I could have the US DEM from a USGS server. Maybe not 10 minutes, but I can request a WMS call GDAL, and it will build for me a local mosaic based on that WMS. It actually supports WebP, which is becoming popular web format, and WebP now exists as a compression option in TIFF. It's not official in TIFF, so you won't be seeing that outside of the geospatial community probably. That's kind of I forget what that's a mix between PNG and GIF or something, I don't know. But you also notice it supports WMTS, which are tiled rasters, so GDAL can actually go grab tiled rasters. Another format that's been optimized by JPL originally, and now Esri, is MRF. That's by, most people know Lucian Plesha at Esri, but he is the master of this format. It is called meta raster format. It is a weird sort of file-based tiled, but it's very performant. It's what they use for all their services, for all their web streaming services. It's so much more optimized than, say, a cloud GeoTIFF. And so that's how you understand what formats are supported in your current build. That will change per build. This will also change per version if something's been updated. To understand what the options are in GeoTIFF, you basically do -format GeoTIFF, and here's all the options. And it takes a while to get used to how to use all these options. But once you start seeing a couple examples, and so if I change that to ISIS3, now I can see, okay, now I have open create copy, and I do have access. I can do virtual IO. And here's the bit types ISIS supports. That's it. ISIS actually didn't used to support UNT16 as of a few years ago. I think it turned it on, but for some reason we added it to the GDAL driver just in case. So I guess we got lucky that it now supports it. And here's a way to, I can tell when I create an ISIS file to say, hey, am I going to be external, and am I going to be internal, or am I going to be a GeoTIFF? So it'll make a label, ISIS label, next to the GeoTIFF. So, PDS4 has a bunch of options. And the biggest option that you need to understand for PDS4 driver is this thing called template, is that it needs that metadata template to be able to run a successful label. So during conversion, I want to point it to a very well-written template file that somebody generated, either by hand or by automation, or the mission generated it. But you need to have that template. It will do it without a template, but it's not going to be a fully valid PDS4 label. So now we get into some examples. I'm going to run this guy, and basically all I'm doing is GDAL translate -OF output format GTIFF in out. So these are just variables in this Jupyter notebook. And again, we're running on the command line because I'm using pound or bang. So the command line is this file to this file. And so what happened? It just runs out and says, I'm done. How many pixels? Done. And if we do a GDAL info of that file, we'll see that it's created, and it now has turned itself into a properly labeled GeoTIFF from the ISIS file. And that's the bulk of it. Now, because GeoTIFF is the default, if you remove that line, it will become a GeoTIFF. Even if the extension is .jpeg, it still will become a GeoTIFF. It doesn't know anything about this extension. It only knows that based on the default, or based on the fact that I put in ISIS3 here. let's do something that should break. PDS3 output driver PDS3 not recognized. We never implemented a writer for PDS3. But now let's change that to VICAR. Oh, I'm using the old version. I'm using 3.0, not 3.1. So that's one way to know that you're not running the latest version if the VICAR driver has no create capabilities. So this is using Sebastian's driver that only has read capabilities. Okay, enough of that. Let's make our GeoTIFF. So because a lot of times we can't use, people don't know what a GeoTIFF is if it's above 8-bit or 16-bit. So we have to share our data as pings or JPEGs. And so this is how easy it is to take an image and make a ping for distribution. But you'll notice that the ping driver doesn't support the input type of, this is a DEM, CTX DEM, float 32. And it tells you that, hey, I only support byte and UN. So let's look at that. I'm gonna use this TUI viewer. This section right here might need to be removed if you're on Windows. I forget what happens if you do that on Windows. Just remove it. I just wanted it spits out a bunch of errors because I think of X Windows. So I just wanted to turn that off. So converting a 32-bit file to a ping looks great, doesn't it? No. So what happened? The actual image, if we go back to the statistics of this file, is minimum minus 3,000, maximum minus 1,300. So there's 0 pixels that are actually valid for a PNG. And by just doing a simple conversion, what happens is that it simply truncates. It will truncate anything that's outside of a valid range of an 8-bit file. So, oh, and I guess I did my stats here to show that. So what do we need to do? There's a flip in GDAL that allows you to scale. So we're scaling. It knows you forced it as an output type of byte. You're saying that I want to take those elevation range and scale it. And so we do that, and now we look at it, and we can see that it's meaningless as a DEM now. If I look at the pixel values, they're 160 instead of in the negative, thousands. But it is something that I can visualize and something you could use for a figure. So just some tips while I'm here. It's also good to specify a no data value, and that will map whatever the input no data is, if it's defined, into 0. And we could do that just same thing. Even better, it will try. Sometimes the scale doesn't work, especially if you haven't built statistics, doesn't work. And in that case, or if you want to do your own stretch, you can specify the min and max. So I can do min in. This is the data range, and then I can specify out min, out max. And why am I going to 1 instead of 0? Because I want to have no data at 0. Simple as that. So now this is a linear stretch, minus 3,000 to 1, minus 1,300 to 255, and it's linear in between. And that's it. That's what GDAL did under the hood. But if it has trouble, just specify min max, or if I want to clip this off a little bit so that I clip off some dirty values.
Trent, what did this command before do, the a_no data version?
It basically forces the caller to be no data. And let's look at TUI view again. If you don't know TUI view, it's great for Linux because it's really hard to find a viewer that understands pyramids on Linux besides QGIS. If I query this, now my caller is set to 0, and I'm hoping there should be no 0 in the data in the valid area. There should be, it should start at 1 up to, and even if you do an auto scale with a no data flag, it should understand that the valid range, the nice range of data should not encompass what my no data is. So what does that mean to be defined as no data? It means that you should be, you're exclusioned out of any math, any mosaicing. It's basically, that is a dead pixel to any application that uses no data. Not all applications understand no data, but
right, and this is an example of PNG doesn't. And so what
yes.
Trent is doing with the -A no data is telling it, the driver, when you write out you're taking something that knows what a no data pixel is, and when you write it out to the PNG, write it out as a value of 0.
Okay.
Yep. Yeah, and so I mean, if I open this up in, you know, Mac Viewer, it's not going to turn off 0, but a GIS will. A GIS will turn off that color, which is just a nicety, right? And the goal is not to turn it off. It's so that it doesn't make it into any algorithmic, you know, calculations. So these are just helper things that you can specify resolution updates. So target resolution 100 meters, 100 by 100. GDAL supports square rectangular pixels, so X and Y can be different, which it will do sometimes automatically if you're not careful. If you want square pixels, then you need to force it to be square pixels. What it does is, like in a map projection, when it goes from square to curved, it will try to automate, it'll try to approximate the best pixel for that reprojection, and sometimes it's rectangular, but you can always override that. So this is just an example of how do I make a one image match another image? How do I make a browse? And this will still be 32-bit, but it's now at 100 pixels, and it's hard to tell, but it's pretty pixely now. And then one of the really nice things for web folks is that you can specify percents. That's actually, I don't really care about percent. What I want to get to is, nope, I don't even have it as an example. Oh yeah, I do. Turn it off. So if say you have a website that the image loves to be 512 on one side, I can specify 0 for the outsize. This is this width and height, I think. And if I set 0, it means then maintain the aspect based on 512. So whatever this input is, I'm setting it that it'll force it to 512 on one side, and the other side will maintain the original aspect. So it's really nice for automating web images and browse images and thumbnails. And so that's a nice trick. But it also does percentages too for the outsize. And then optional, I'm not going to go through these. These are to do on your own. There's a bunch of tools. These are also mostly available in ASP. So, you know, take these with a grain of salt. But let's run through one, a colorize. It's really easy to actually make a QGIS color ramp, save it out, and use it in GDAL for 100 files, which is nice. That's what the color ramp looks like from QGIS. I had to comment out one line, which is explained here, and then I apply that to a PNG, and got a nice color ramp. Slope, I'm actually going to run a 32-bit slope using Horn, which is the default, and then I ran a color ramp on that so I can make a really garish safe landing site map. And color merge. There's a little Python program example. And the only reason I wanted to point this out is that it's here. It's a really good example for manipulating pixels in GDAL. And there's a ton. I'm just going to go here real quick. There's a ton of samples next to this HSV merge. So it's not very fast. So if you're going to use it in mass, but all these are really good examples of how to use the Python API for GDAL, the native one, not Rasterio. Okay, I'm going to close that. Actually, I guess I need to properly cancel. Half the time I don't know how to shut down Jupyter Notebooks correctly. Does anybody have any tips?
Depends on if you're running lab or notebook, unfortunately.
Yeah, that's true. these two are pretty quick, and again, I'm barely touching the surface of what we can do.
But before we start projecting, I think related to that is reading the GDAL info properly, like you advised. And what always confused me is at the beginning, this radius information with the ellipsoid. When it says ellipsoid, I kind of expect that I get the information of 2 radii, but I only see 1 radii number. So how can it be an ellipsoid, but I only get 1 radii number displayed?
So if you only see 1 number, there's actually always 2, but the second number is probably 0, which means that whoever defined that image was on a perfect sphere. So we'll look at more GDAL info, especially as it concerns to map projections. And the problem with map projections is because of what I would say we've sort of done to ourselves in the community, we've made this tricky, and there's just no way around it. But you kind of learn what you have to do to make it work, and that's one of the reasons why I've had so much trouble with this well-known text 2 standard, was because it gets us Traxel, it gets us east and west, it gets us almost everything we need, but it doesn't allow us to do a proper ocentric without a Z component. It allows us to do body center, body fixed with X, Y, Z, and I can fully define Mars as an ellipse or a Traxel. But once I go down to a 2-parameter, an X and Y ocentric, that API, that standard doesn't allow for it, and it's driving me nuts. So we've done some tricks, and it's a workaround still, but it's the last workaround till we potentially update the standard, which is going to be tough because I think it's an ISO standard. So if that just forget about I said all that, because it gets to be confusing really fast. But so some of the things I'm actually going to introduce some of the Python API, because a lot of times parsing a command line is just wrong. You don't want to do it that way. And even though I show examples of how to do it here, it's just not necessarily convenient or good, because you can get yourself into trouble. So if you are writing scripts, you kind of do want to use their Python API or Rasterio. So basically here I'm gonna import GDAL, and I'm gonna check its version. So there's this GDAL __version, very Pythonic. I'm gonna define my test images, which I have the test albedo map because it was nice and tiny and it's global. And I'm gonna find an output South Pole. So we're gonna go from a global image to a South Pole, and it's not as easy as you would hope, which is unfortunate. It actually, it's not horrible, but it's kind of a 2-step, which doesn't always make sense. And so that's kind of what I'm explaining here. So we're going through this long-winded gathering information just to do a polar image, but I just want to show you the different options. So the image looks like this. It's near global. It doesn't go all the way to the poles. Gets close. And then I'm actually going to import pretty print, which helps with printing JSON blocks. And it's just pretty print. I'm actually parsing the output of GDAL info, and I'm grabbing this thing called corner coordinates. Don't ask me why, but I'm just showing you can parse GDAL info if you really have to. And the flag here is that, hey, GDAL, give me the label in JSON. This is what I mean by I should be able to give me the label JSON on an ISIS cube, and it should be the full label. Give me the PDS4 label as JSON, and it should be the full label. It's not going to be all the little parts that ISIS supports, but it should be the full label. So
wait, you're going out to the command line to run GDAL info?
Shh.
Isn't there? Okay,
No.
I'll stick quiet.
So I wanted to just show you that this is a bad way to do it.
There's another way. So to get like sort of if you scroll over, you're trying to get the standard out back into Python. Is that the question?
Yeah, that's kind of what I'm doing here. It's just goofy.
There's a really fun Python library that I use for all my work called SH, which automatically wraps everything in your path as Python commands, and you can directly do a sh.ls.
And yeah, I mean, I would totally not recommend this. That's why I'm sort of, I just want to show you. But the right way to do it is this: is that you want to import. I don't even think you have. Yeah, import JSON, and you actually use GDAL to open up the Python wrapper of GDAL to open it up and ask for it in JSON. And it writes to a JSON block straight away. And now I can do my JSON dumps because it actually is just a string at first. And then I can properly get the corner coordinates using a JSON dive. So this is the right way to do it. And then I get the extent. So you still have to parse the JSON object, but this is the right way to do it. But if you're desperate, you can jump to a standard out. So why am I doing all this? Really, I just want to show different methods to get these values into. I want to get out the extents because this is important for my finals map projection. And I look at these numbers and I'm like, I don't know what minus 10 million is. Who cares? That's in meters. That's the extent in the map projection, but that doesn't help me any. I don't know what that means. I mean, the GDAL info will tell me what it is, and here's where we have this image actually goes beyond 90, which is wrong, but it's because it has padding. So it's a little weird to see, and you're gonna see that this doesn't impact the run, but it actually warns you that, hey, there's some problems here that you probably should be aware of. I know that it's set as no data on the outside, so I'm good. Notice that when I'm running a GDAL open, to be able to release the memory, you always want to set data set equals none when you're done with it. What I'm doing here is I'm asking for a bunch of variables from the get geotransform, and I'm actually using kind of a janky method to get out the lower right version. I'm using this geotransform information to calculate what the extent is in pixels. So I'm asking for the pixel size and then how many pixels and then the resolution, and I just add it to the upper left corner. Doesn't GDAL have that built in? Kind of, but you still have to do something. You still have to, this is even a better way to do it. This is not in your Jupyter notebook. It's a new section, but I should be doing apply geotransform. And this will make sure that if there's any weird rotation in the geotransform, which is how the image gets referenced, that it will actually take into consideration when it calculates the lower left. So if I run that, I get the same information. This is based on a really good little workshop that Yvonne put together. So we're getting into the Python. We're getting how to extract things, but this still doesn't help me. I'm still in this meter coordinates. I want to make a South Pole map from 60 to 90, and this doesn't help me. This doesn't do anything for me. So there's a bunch of little routines that allow me to look for projections, and there's a bunch of routines that allow me to ask for pixel locations. And I really recommend getting used to GDAL SRS info, especially if you're a projection nerd. GDAL SRS info allows you to specify what style of projection that you want to output. There's different ways to specify projections. This is called the PROJ4 method: equirectangular, equidistant, cylindrical, and then these are the parameters. And this is the projection that got HiRise into trouble, because HiRise, unbeknownst to them, and probably based on information I gave them, said, hey, ISIS maps lat 0 to here, when it actually should have mapped its internal lat 0 or center lat to true scale. And so every HiRise equidistant cylindrical label in a GeoJPEG is incorrect, and that it maps the scale, the true scale, latitude of true scale to the lat 0, not here. That's where we got ourselves into trouble. You'll also notice that because this is a sphere, it only reports the radius as a single value. So you are correct. And in this example, this image is not an ellipse, it's a sphere, and it reports it as such. So what else can we do? Let me see if I do well-known text. Oh, I'm doing stupid parsing things again. And that's well-known. That's the original well-known text. Well-known text 2 looks the same, but there's slight differences. So I used to try to stay away from PROJ4 as much as possible, just because it's so, but I'm starting to get used to it, starting to like it. But it's for the standard user, this means nothing. If you look at shapefiles, they have a PROJ projection file, and they use this thing called well-known text, which is much more verbose. I wish web services could use this because it tells you where the center is. It tells you each parameter. It tells you the name. It doesn't say lat TS. It says longitude of natural origin. Actually, that's not the right one. It's the latitude of first standard parallel, just scale true lat. It tells you what a meter means. A meter is defined by the EPSG. There's different lengths of meters. Hopefully nobody uses those. But there's different lengths for degrees too. And so it tells you which degree it's using. So I like the well-known text much more than this because it's more human readable. But GDAL uses either, and it uses PROJ4, well-known text 1, well-known text 2. So now using Python, where are we going with this? We want to get the projection using Python, and same thing. We're grabbing, importing. Go ahead.
Out of curiosity, what are the empty parts of the PROJ list that's coming back? Is that being used somewhere, or can I safely, like you did, always sample out the first position of the thing?
That's because I'm doing a command line dump. Don't do that.
Oh,
if you're going to use the Python dump, which is actually a little bit awkward because you have to convert I guess the get projection does well-known text, and then you have to convert it to PROJ4 in GDAL. I don't think there's a way. Maybe there is a flag here that says give it to me as PROJ4, but right now you actually have to create a spatial reference and import it from. This is how you can go back and forth from well-known text to PROJ in code. And there's actually, because Esri decided to do, they released well-known text standard before it was standardized. There's slightly different. So there's actually a morph from Esri well-known text and morph to Esri well-known text. Unfortunate. Sometimes people don't wait for standards to mature, and then the standards become not standardized. Unfortunate. So I actually didn't tell anybody that they needed Rasterio here, but I just wanted to quickly show. So this might break if you run this. I wanted to show how to get it from Rasterio, which is well-known text, the default again. So why am I doing all this? Because I'm still trying to get you to a South Pole map projection. Also notice that part of the PROJ 7 updates is that GDAL will have all these planetary codes inside of a database that ships with GDAL, and QGIS and map server should hopefully be able to use them. But for now, there is this website that GDAL can actually grab well-known text or PROJ strings from, and so I'm telling it, hey, go grab me this IU 2000 code called 4990, which is 499 is the NAIF code, 00 is our projection code for Mars, and here's the AB radius for lat lon. So this will actually force it into decimal degrees out of meters. And why am I doing? I'm sorry.
I was wondering if there's a cheat sheet somewhere where I can see how I create this 49900 for other objects.
Yeah, there is a GitHub location, but there's also just the NAIF. The NAIF will tell you all the codes. And so part of that GitHub is that the NAIF that defines these codes. And so so 499 is the NAIF code for Mars. And then we add 00 to allow for 100 different projection types. I know it's weird, but it's the best thing we could think of in 2006. And we're actually changing it up a slight bit for web access. We're going to put a comma between those. We're going to put, this is actually going to be a versioned thing. so that you can specify different versions instead of having the namespaces with the date. Don't worry about that yet. So what am I doing here? There's another helper routine that allows you to go from any XY meters to lat/lon or vice versa. And all I'm showing here is an awkward method within this Jupyter notebook to do that. I'm going from my source projection of Mars to my target projection of CTX. And I actually have to, it's an interactive command. This GDAL transform is interactive. So you actually send it a text file with XYZs, or you send it XYs, or it could be either, or you send it or you do it on the command line, or you can, force values into it. So I'm going to echo 0 longitude and -60 latitude into my geotransform command. And it's saying, I want to go from Mars, latitude, longitude, latitude, into CTX map projection. And then I do some ghetto things to do parsing. I know, lame parsing, but it works. And I get an error. Ah, crap, because I didn't run this. No. Oh, great.
And importantly, you seem to change the radius model. I mean, the shape model of the planet.
I did, and GDAL will take care of that.
Yeah.
I did. Oh, what am I doing? Let me just see. I did test this. No, it's giving me an error one. Okay, let's pretend that worked. And what would it return? It would have returned what? Why isn't it working? It would have returned the this location, longitude, latitude in meters, in this funky map projection space here. So I would have actually had, I think it's minus 300,000 or something like that.
Yeah, it works here. It's -3556282.
Okay, and I have that. Let's see if I can get this to run. No, I must. Oh, you know what? I messed up my proj string because I got rid of this. So bad on me. That should fix it. There we go. So quickly, you can now understand. I have a list of lat/lons, and I need to make them into XY meters in some projection. GDAL transform can do it for you. It's it's a weird way to do it. There's ways to do it in Python too, but that's one way to do it. I have a bunch of XYs in meters, and I have no idea what their lat/lon is. You can throw it through there.
So how
and in
do
Python,
I know now where to go?
Yeah, and here's the Python way to do it. Here I can do what's called transform point, and I could loop over a huge set of files. And just as a bonus, there's another program called GDAL location info. So say I have a lat/lon and I want to get the pixel value from a map. I can use this simple little GDAL command to grab me not only the location in pixels from a given meter location or lat/lon location, but it also give me the value of that pixel. Kind of nice. So here we're getting the value at that -60, and here we're getting it at the center of the map, 0, 0. So pixel value.
So, but you used the source coordinate system Mars 2000. How do I know that I'm supposed to use that?
Good question. And let's actually let's do a little test. I'm actually going to take that. Okay, somebody remember those decimals. Okay, it's the same.
Yeah.
So that's because this is where it gets into the weird thing about projections, is that a lot of projections, even if it is on an ellipse, use a spherical equation. And that, to me, if thinking real quickly, is that equirectangular map projection is only defined on a sphere. Sorry, needed to stand up. And so pushing it through the equations to an ellipse doesn't change anything. Am I thinking about that right? Might need to think about that. So in general, I set Mars as a sphere. And I know a lot of people don't like that, but it's what a lot of map projections do. It's safe, and then ocentric and ographic are the same, and you don't have to worry about meter errors. So whether or not you decide to use Mars as an ellipse or Mars as a sphere, in general, using Mars as a sphere will be more interoperable, and it will just, you will incur a tiny bit of error and maybe some calculations, but not enough to worry about. So, that it gets to be a long discussion, but that's kind of my 2 cents on it, is that in general, I like to see Mars set as a sphere.
But my question is a little bit actually more top level, more easier. It's like, how would I know about that there's such thing that's called Mars 2000? And how would I know that that's the right thing to use at which point? So it's like, if, for example, I don't understand, if everything would be spherical, do I have a need of Mars 2000? I don't understand it.
So Mars 2000 is just a shorthand for some particular PROJ string, right? So if you want to keep in your mind this index between a bunch of projections and like their fancy names, you can do that. That's too much for my brain. I just use PROJ strings because they're descriptive, and I can exactly see what's what.
Yeah, and I didn't mean to confuse. This whole spatial reference thing is not really meant for our daily lives. It's meant for web services, which is why WMSs and WFSs have such a hard time, because those standards are based on codes that are used on Earth. These codes were trying to emulate those Earth codes so that we could use web services and Planetary. And it's been 15 years and we're still struggling with that because we haven't been able to impact the original standards broadly enough. So I'm gonna breeze through here. So I'm gonna keep going down, and the point of this is that.
So there was a question in the chat.
Yes.
Trent. So we went from lat long to a pixel number. Do you have an example for the inverse?
Yeah, and I actually said I think here we go. Now let's go backwards. So our target is Mars, which is that PROJ string, and our source is the map projection. And so I'm echoing these giant values in X, Y, and I get back 0, minus 60. So that's the inverse. I'm going to Mars from an XY meter map projection. So that's how I can understand what lat lon a value is. And why am I doing all this? It's because I want to crop using that meter value. So I'm actually going to send a cropping command to my image using that minus 60 in meters. And what does that afford me? It affords me this image, which is just the South Pole from that global image. So why did I have to do that? Because if I don't crop an image, oops, that's a different way to do it. If I don't crop that image, and now I'm going to project, I'm going to use the global image. And you can see that it's giving me these errors because it goes beyond 90. And GDAL goes, this is, they've been fixing these left and right. But when I send GDAL a global image and say, go to polar, it's like, you didn't tell me anything. You didn't tell me the extent. I don't know what to do. It's global. What did I, is it doing, how far does it go out? I'm not sure how it made up its mind to do that. So by doing a virtual crop, I just basically wrote out a new TIFF or a virtual TIFF, which is called a VRT. Now when I actually do this projection using that crop, I get polar. I get a nice polar and there's no data in the center. So in GDAL, a lot of times if you want to crop at a boundary, you need to crop it first. Now, and let's go sinusoidal. And here we have sinusoidal. So again, prod strings look funny, but now I have my centers 180 and 0. And I'm not going to run this. This is how to test doing multi-threaded map projections. But I wanted to point out that I did all this stuff to figure out XY's lat lons when now there's actually a newer option. If I can find the darn thing. I think I lost it. Nope, I lost it somewhere. There's a way to do it in one fell swoop now. So you don't have to go through cropping. No, you do. You do have to go through cropping.
Do you mean the command line GDAL translate that has this global crop parameter?
Yeah, I'm gonna.
There was 710 here.
Oh, here it is. Sorry, thank you. So a new option lets us do it in one command. Let's see if this worked. So I'm giving it a PROJ when I'm giving it the cropping. And oh, but notice that was just to crop it. So I didn't have to crop it in XY. I can crop it in meters, but I still have to crop it before I go to polar. That was the whole point of this, is that no matter how you crop it, whether it's in meters or using this PROJ trick that's been around for a while, but it's nice. And notice that if I just send this without the map projection, it would have cropped out a little tiny portion in the center because it thinks it's meters. I have to say that, hey, my cropping window is in this projection, and that's a nice new add-on. But I want you to understand how to do it in meters too, because it's critically important to know what a map projection means, and that map projections are in meters. I'm starting to run out of time. I'm going to fire off. And I don't really think the third or fourth have anything critical. Oops. Sorry. But and I think there's enough information there to run through them yourselves. I will post these as GISs or PDFs in their final form, so you can copy and paste from them too. This is a fun little thing that says I have two images. They're not in the same map projection, and how do I get them into the same map projection? And so basically we're doing the same tricks. We're grabbing the projection from one, we're putting it into a string. Again, don't use this method. And then we're telling GDAL warp to map project from one to another. So what does this mean? This means that both images have to have a map projection. To get to one to another, often in the wild, you'll find an image that is map projected that doesn't have a map projection label. That gets to be tricky. And as much as I'd like to say I can help you, you're going to have to do some homework, whether it's a global image or not. If it's global, it's really easy. If it's not, then it becomes really hard to define a map projection on that. But you can use tricks like that lat-lon tool to figure out what it is in XY to apply a transform. And that's something I should do as a lesson. But really all this is doing is it's great. It's figuring out the PROJ4 string, and then it's making one match to another. So how do we know one of the things that's maybe good or bad about let me just run it. TUIView is that it's a very, very simple viewer. And immediately TUIView will submit an error to say, hey, I don't understand. These are in 2 map projections and it won't project one to another. So I can tell that they're not working. So to be able to view them, and QGIS can do on-the-fly projections. But to match these projections, I can simply do this, and now I have a match. And so I had to do a little homework to extract the PROJ string, but then, and I'm not doing anything with resolution. This is still 1 meter, the high rise, and the CTX is what, 6 meter? No, 20 meter. So they're at different resolutions, but TUIView is smart enough to know how to display those, but they have to be in the same. Here's a bonus section, how to run calc to get a difference from those two. And this is a high rise versus a CTX. It knows how to deal with no data. And you can see that there's residual jitter in one of the images. So you can actually see that jitter get enhanced from the CTX DEM to the high rise DTM. You can see the noise because there's a lot more detail in high rise than CTX. So it looks like a hillshade almost, or an image, but that's just the difference in the details. So to be able to run GDAL calc, they do have to be the exact same resolution. And so this little routine here called match projection is a Python script in your package that actually does that for you. It's a little bit of code that matches the exact number of lines and pixels. And so this little function, match projection, is a little Python script in that does that. It matches the projection and the resolution, such that TUIView doesn't need that, but GDAL calc does. And I just want to introduce you to Rasterio. This is all straight out of this Jupyter Notebook example, and it has the data is just the CTX. It is very much more Pythonic than the GDAL API wrapper. Raster.openctx, great. That's simple. So now I have that. And it has some helper. This is actually running matplotlib. And so I can do a little histogram as a figure. And I can do color bars out, again, matplotlib. There's helper plot functions in Rasterio that allow me to understand the XY coordinates. So it actually maps the columns and rows into meters, which is nice. Otherwise, that gets to be a little tricky, straight up matplotlib. Here's actually a really cool trick where I'm actually doing a virtual projection to degrees, and then I'm plotting that. So I'm actually writing out a virtual file in degrees to a Mars sphere, and now I can plot it in degrees. Of course, you could have mapped the meters to degrees, but that would have been also kind of tricky. So this is a tricky way to do a virtual map projection. It's only done in memory. And then I didn't want to go over any of this, but this is just, you don't live in Python if you don't use NumPy, especially with rasters. So this is basically how to get from Rasterio to NumPy. And there's a little function I found called hillshade, uses NumPy, bunch of math. Doesn't do a great job, but it's interesting. So I've loaded that function, and now I'll run that function, and I can plot that function. And then I added a section to that workbook that says, okay, now I have a file in memory, I have this hillshade, how do I actually write out a new GeoTIFF such that it understands no data and it understands the map projection. And so everything's, it's a solid GeoTIFF. It's not just a pretty JPEG. But notice I can set the driver here. I can set the driver to output a cube or a PDS4 or a VICAR. So right from the rasterio API, you can access how to write any style of file, and that will be a fully vetted map projected ISIS cube, hopefully. And if we run this, writes it out to a new GeoTIFF, and I can view that in TUIView. Hillshade algorithm's a little harsh, but again, it's just this numpy function. So I'm way past time, sorry. There's a lot of information here, and I know it's basic for some. I know it's probably like, whoa, what just happened for others? But feel free to give me feedback. I'd really like to understand, kind of as we go on, use cases for GDAL specific questions or requirements. If you have anything that you want to add, that you want to see, that you need to be fixed, feel free to do your own pull request or GitHub issues on GDAL. But really, that's a brief overview, and I think it is getting used in a lot of places, and so we want to make sure that it's correct. So thanks for your time, and sorry for the overage, but that's typical of me. So any last questions?